Today we are going to create a project in Cadence. Open Red Hat and click on Applications on top right corner. Yeah, click on System Tools. System Tools. Click on Terminal. And now the terminal will open. Type CSH. Enter. And up arrow. Click on up arrow. Yeah. Enter. Click on up arrow and select a Virtuoso. Enter. Then the Virtuoso window will be open. Minimize the terminal and maximize the Virtuoso window. And click on File. Click on New. Click on Library. Name a library. In technology file, click on Reference Existing Technology Libraries. Apply. Click on Apply. And search for GPDK 180. There, GPDK 180, and click on right side arrow and OK. Click on Apply. Click on Apply. OK. Click on Into. And again click on File, New, Cell View. Name your project, maybe inverter or an AND or something. And in the library, select your library name and name the project as your wish and click on OK. Session. Now maximize the screen. And now I am showing you how to build an AND gate. Click on I. In the library, select GPDK 180. In that cell view, type PMOS. For NAND gate, we use 2 PMOS and NMOS. PMOS. And click on symbol. And here, drag this and right click, left click. Okay. And we need 2 PMOS, so 2 PMOS. And for NMOS, same again, escape, click on escape, click on I. In cell view, type NMOS. After NMOS, place the NMOS here and here and escape, give escape. We need 2 inputs, 1 VDD and 1 ground and 1 output. So click on P. Name your input as A and direction as input and click here. 1 input will be there, and again click on escape, click on P, name it as B and direction input and put it here, and again click on escape and click on P, name it as VDC and a direction as input output and place it here. Again escape, click on P, name it as ground GND, direction input and output and place it as here, and click on again escape, click on P, name it as output out, direction as out and place it here, escape. Now we have to connect the circuit. I will show you how to connect circuit. Click on W, then you will get a wire. First of all, for PMOS, click here and here, here and here, here and here, here and here. Now we have to connect the inputs. So for click on that input and drag the line to here. So like that we have to do for everything. For here I will show you. So like this, connect everything. So after completing of putting the wires, now check for errors. From the left side, click on check and errors, check and save, and click here Virtuoso. Here Virtuoso, and you can see here with no errors, there is no errors, and click on Virtuoso schematic, and now click on create. I will show you from here, create, and click on cell view, from cell view, and name it as NAND and click on apply, and you will see here. So in the left pins there is only A and B, and right pins there is output, and top pins we have VDC, and bottom pins we have ground, but we see that the ground is on the top pin. So click on control X in the bottom pin, control V, apply, click on apply. Yeah, you will see the symbol here, NAND symbol, and minimize it and click on OK, and you will see here, and click on OK again, and you click on modify. After this, click on here, click on file, new, and library name as it is same, and click on NAND cell as TB for test bench, and click on OK, and you will get another page. Okay, now click on I, and in the library name put your first given library name, and select in the cell view, click on NAND, you will get NAND symbol, and click here, place here, and escape. And now you have to place for 2 inputs you have to place 2 vpulse. So click on I, and the library select analog library. In vpulse vdc ground will be there in analog library. Click on analog library, and in the cell view click on and type vpulse, click on vpulse, and put here, and put 1 vpulse here and 1 vpulse here, and we take 2 vpulse, and we will need 1 vdc also. So again click on I in the place of a vpulse, enter vdc, you will get a vdc symbol, and place it here, and escape. And again we need a ground, so click on I in the cell view, type GND for ground, GND, click on ground and symbol, and you will get a symbol. And we need 3 grounds, 1 ground here, 1 ground here, 1 ground here, and 1 ground here, and we need an output. For output we will take pin, output pin, so click on P and name it as Y, and output, direction output, and place it here, escape. Again we need to use as click on W, and connect these things, connect this output to this output, and input to input, and negative to ground, click like that, connect it. So again if you have to rotate that, click on here, click on the rotate symbol, and rotate right or left. Click on, I think rotate right, yeah, and if you click here, then it will be rotated. For left also, click on escape, and click here, rotate to the left, and click on here like that, and connect all the circuit. Okay, after connecting the circuit, check and save, click on check and save, and after checking and save, check here for errors. Yeah, here you can see there is no errors. So again click on schematic, click on the vpulse component, and click on Q, then you will get this, and click on voltage, and give the voltage as 1.8, and period as 20 nanos, and rise time as 1n, and fall time as 1n, and pulse width as 10n. And after this click on apply. Okay, and for this also, for vpulse 2 also, click here and click on Q, and again give the same values, 1.8, period as 20n, rise time as 1n, fall time as 1n, pulse width as 10n, and click on apply. Okay, now click on the VDC here, and click on Q, and put the DC voltage as 1.8, and apply. Okay, now after this go to launch ADEL, and you will see this, and now click on analysis, choose, and make it as here tran, and stop time as 200 n, and moderate, and apply. Okay, and again click on analysis, choose, and here click on DC, and save DC point, and here click on component parameter, and here click on select component. You need to select any one component, so I am selecting the vpulse component, and click on DC, VDC, DC voltage, and OK. And now go to the top there, and you will choose the choosing analysis, and click here, and start as 0, and put one stop as 1.8. After this click on apply. Okay, After this, again go to the ADL, which will be present here, ADL file, and now click on outputs and click on to be plotted and click on select on design. Now you need to select the input and output wires, so click on here input wire 1 and input wire 2 and click on here input wire output wire, and after clicking and again go to the ADL file and click and run this. Click on here and you will get the output plot here, so you can check the output plot here.